Okay, so good day everyone. I am Miss Leona May Cervantes. You can call me Miss Leona, your teacher for General Mathematics. So let's start. Module 2, Learning Competencies. The learner can represent real-life situations using functions, including piecewise functions. The learner can evaluate a function. The learner can perform addition, subtraction, multiplication, division, and composition of functions. The learner can solve problems involving functions. Next, functions and their graphs. Do you believe in the saying, no man is an island? So, the world is a world of relationships. It can be mother to her child, teacher to his or her students, flag to a country, employer to his or her employees, passengers to the bus where they are going to ride. Next, relations. It is a rule that relates values from a set of values called the domain to the second set of values called the range. It is a rule that when you plug in an input, you will have one or more output. It is the pairing or association of some kind between quantities that can be one to many, or many to one. So relation is a set of ordered pairs. If x and y are elements of these sets, and if a relation exists between x and y, then we say that x corresponds to y or that y depends on x. We may represent it as the ordered pair of x and y. Next, functions. It is a relation where each element in the domain is related to only one value by some rule. It is a relation that when you plug in an input, you will have only one output. It is the pairing or association of some kind between quantities that can be one to one or one to many. So functions are important mathematical equations that can have real-life applications. Functions arise whenever two things are related to each other or one quantity depends on another by some type of rule or correspondence. So for example, the amount of weight of a person gains is a function of how much food he eats. Next, another example, if a student's grade in a test depends on the number of hours he studies, his grade on the test is a function of the number of hours he studies. Another example is the amount of money a worker makes is a function of how many hours he works. So a function is used to describe how one variable depends on one another. So for instance, as I stated previously, the amount of money a worker makes is a function of how many hours he works. The number of hours the worker spends on his job is called the independent variable, while the amount of money he makes is called the dependent variable. Note that for each independent variable, there exists only one corresponding dependent variable. So now we have different types of relation. We have one-to-one. For example, we have mangga and bagoong, ube and makapuno, puto and dinuguan. Next, we also have many-to-one relation. So for example, pulo, marinig, and mamatid to Kapuyaw. Another example is malitlit and dita to Santa Rosa. Next, another type of relation is one-to-many relation. So we have time to family, friends, studying, and sports. Next question, are all relation can be a function? So remember, all functions are relation, but not all relations are function. One-to-one and many-to-one relations can be considered as functions. So, one-to-many is not considered as function. Okay? Next, we have different ways of expressing or determining functions and relations. First one, we have set of ordered pairs, table of values, mappings, graphs, and equations. First, let's have set of ordered pairs. An ordered pair x and y is composed of two coordinates, the x-coordinate or the abscissa and the y-coordinate or the ordinate. In a set of ordered pairs, the domain is the set of all x-coordinates or first coordinates, while the range is the set of all the y-coordinates or the second coordinates. The set of ordered pairs can be considered as function if every element in the set is composed of different x and y coordinates, and no common x coordinates exist in the given set. Now, let's examine the following example. Determine either function or relation. Number 1, or set A, we have 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10. So for the domain, we have 1, 2, 3, 4, and 5. Since it is not repeated, then this is an example of function. Next, we have 2 and negative 3, 3 and negative 2, 4 and negative 1, 5 and 0, 7 and 2. X coordinates are 2, 3, 4, 5, and 7. Since it is all unique or not repeated, then this is an example of function. Next, we have 1 and 1, 1 and negative 1, 2 and 2, 2 and negative 2, 3 and 3, 3 and negative 3, 4 and 4, 4 and negative 4. Since the domains 1, 2, 3, and 4 are repeated, then this is an example of relation. Next, we have negative 1 and 1, 1 and positive 1, negative 2 and 4, negative 2 and 4, positive 2 and 4, negative 3 and 9, positive 3, and 9. Domains or x coordinates are negative 1, positive 1, negative 2, negative 2, positive 2, negative 3, and positive 3. Since negative 2 is repeated, then this is an example of relation. Next, table of values. The set of ordered pairs can be written as the table of values, still composed of x and y coordinates. So the x coordinates are written on the first row, and below are the y coordinates. Now examine the following example. Determine either function or relation. So for x, we have positive 1, positive 2, positive 3, positive 4, positive 5. And for y, we have positive 2, positive 4, positive 6, positive 8, and positive 10. Since the x coordinates or the domain are all unique, then this is considered as function. Next, for x, we have positive 1, negative 2, positive 3, positive 7, negative 2, positive 5, and positive 6. For y, we have positive 3, positive 4, positive 5, positive 8, positive 6, positive 9, and positive 7. Since the domain or the x-coordinate negative 2 is repeated, then this is considered as relation. Next, for x, we have negative 1, negative 2, negative 3, negative 4, negative 5. For y, positive 1, positive 4, positive 9, positive 16, positive 25. Next, since the domains are all unique or not repeated, then this is considered as a function. Next, let's proceed to mappings. Functions can be written as mappings in which the values on the left side, which represent the x coordinates, will be matched with the values on the right, which represent the y coordinates. Again, left side x coordinates, right side y coordinates. So examine the following example. Determine either function or relation. Okay, so for first example, x coordinates are positive 3, positive 6, positive 9, positive 12. And for y, we have negative 1. Since this is an example of many-to-one relation, and many-to-one relation is considered as function, then this is an example of function. So when we express this as an ordered pair, we have positive 3 and negative 1, positive 6 and negative 1, positive 9 and negative 1, positive 12 and negative 1. Next, Another example, we have positive 1, 2 positive 1, and negative 1. Positive 2 to positive 2 and negative 2. Positive 3 to positive 3 and negative 3. When we express this as an ordered pair, we have positive 1 and positive 1, positive 1 and negative 1, positive 2 and positive 2, positive 2 and negative 2, positive 3 and positive 3, positive 3 and negative 3. Since the domain 1, 2, and 3 is connected or repeated, then this is an example of relations. Next, okay, we have negative 1 to positive 2, 0 to positive 2, positive 1 to negative 3, positive 2 to negative 2, positive 8 to negative 3. Since the x or the domain are all unique, are not repeated, then this is an example of function. Next, next is graph. So the graph must always pass the vertical line test to determine that it is a function. So we have vertical line test. It is a test defines y as a function of x if no vertical line intersects the graph in more than one point. Okay? Okay, so when we draw a vertical line here, the vertical line will pass one point in this graph. So this is considered as function. Next, okay, so let's draw a vertical line. So it will pass one point in this graph. So this is an example of function. Next, another example. Okay, so here, as you can see, the vertical line passes through 2 points in this graph. So this is an example of relation. Next. Okay, so again, this graph or the vertical line touches 2 points in this graph. So this is an example of relation. Next. Okay, so let's have another example of function. Okay, so this is an example of function since the vertical line touches only 1 point in this graph. Next, another example. Okay, so as you can see, it touches 3 points in this graph. So this is considered as relation. Next. Another example. Sorry, so another example. Okay, so this is an example of function. Since the vertical line touches only 1 point in the in our graph. Next, another example. Okay, since it touches 2 points in this graph, then this is an example of relation. Next, another example. Okay, so since the vertical line touches 1 point, then this is an example of function. Next, now let us proceed to equation. So equation concentrate in y variable or range. Its exponent must always be in the odd numbers to determine that it is a function, whatever the degree of the x variable or the domain. So unlike set of ordered pair, table of values, mappings, and graph, where we focus on the x or the domain, now we will focus on the range or the y variable. So when the exponent of the y variable or range is odd, it is considered as function. And when the exponent of the y variable or the range is even number, then it is considered as relation. Okay? So first example, y plus x equals 4. The exponent of y is 1, which is an odd number. Then this is considered as function. Next, another example, we have y squared plus x equals 4. Since the exponent of y is 2, which is an even number, then y squared plus x equals 4 is an example of relation. Next, another example. We have y plus x squared equals 4. Since the exponent of y is 1, which is an odd number, then y plus x squared equals 4 is an example of function. Next, next we have y squared plus x squared equals 4. Since the exponent of y is positive 2, which is an even number, then y squared plus x squared equals 4 is an example of relation. Next, We have y equals x squared plus 2x plus 3. The exponent of y is 1, which is an odd number. So this is considered as function. Next, next example, we have y squared equals 4x. Exponent of y or range is 2, which is an even number. So this is considered as relation. Next, okay, so we have y equals 3x minus 4. Exponent of y is 1, which is an odd number. So y equals 3x minus 4 is an example of function. Next, next we have y equals x squared. Exponent of y is 1. Then, which is an odd number. So y equals x squared is considered as function. Next, y raised to 4 equals 4x plus 16. Since 4 is an even number, then this is considered as relation. So y raised to 4 equals 4x plus 16 is an example of relation. Next, so we have x squared plus y squared equals 1. Exponent of y is 2, which is an even number. So x squared plus y squared equals 1 is an example of relation. Next, we have y equals 2x plus 1. Exponent of y is 1, which is an odd number. Then y equals 2x plus 1 is an example of function. Next, okay, so now let's proceed to using notation to specify domain and range. So we use inequalities and lists to describe the domain of functions. We can also use inequalities or other statements that might define sets of values or data to describe the behavior of the variable in set builder notation. Next, so for example, the set of all x values such that positive 10 is less than or equal to x and x is less than 30 describes the behavior of x in set builder notation. So the phrases are read as the set of, okay, and the vertical bar is read as such that. So we would read the set builder notation as the set of x values such that 10 is less than or equal to x and x is less than 30. Next, okay. So remember braces, the set of vertical bar such that shaded dot means included, then square bracket also means included, then this non-shaded dot is considered as not included, and also parenthesis means not included. These arrows means continuous. Next, now let's proceed to set builder notation and interval notation. So set builder notation is a method of specifying a set of elements that satisfy a certain condition. It takes the form the set of all x values such that statement about x, which is read as the set of all x values such that the statement about x is true. So for example, the set of all x values such that 4 is less than x and x is less than or equal to 12. Again, the set of all x values such that 4 is less than x and x is less than or equal to 12. Next, interval notation. Interval notation is a way of describing sets that include all real numbers between a lower limit that may or may not be included and an upper limit that may or may not be included. So the endpoint values are listed between brackets or parentheses. So a square bracket indicates inclusion in the set, and a parenthesis indicates exclusion from the set. So for example, we have parenthesis +4, then +12 square bracket. Next, again, square bracket, it means it is included. Then parenthesis, it means not included. Now let's have an example. So first example, +5, not shaded or not included. Next, +10, shaded or included. So inequality notation, 5 is less than h, and h is less than or equal to 10. Okay? So remember, if it is not shaded or not included, then we will not put an equal or underline. Okay? Next, if it is shaded or included, then we will put an underline or equal. Okay? So again, inequality notation, 5 is less than, not shaded or not included. 5 is less than h, and h is less than or equal 10. Set builder notation, we have the set of all h such that 5 is less than h, and h is less than or equal to 10. Next, interval notation, we have +5, not shaded or not included. So we will use parentheses. Next, +10, shaded or included. So we will use square bracket. Okay. Next, another example, we have +5, shaded or included. +10, not shaded or not included. So inequality notation, since +5 is shaded or included, then we will put an underline or equal. Next, since +10 is not shaded or not included, then we will not put an underline or equal. Okay, so inequality notation, we have 5 less than or equal to h, and h is less than 10. Next, set builder notation, we have the set of all h such that 5 is less than or equal to h, and h is less than 10. Next, interval notation, we have the square bracket, +5, +10, parentheses. Okay, so since +5 is shaded or included, then we will use square bracket. +10, not shaded or not included, so we will use parentheses. Next, third example, we have Positive 5, not shaded or not included. Positive 10, not shaded, not included. Since positive 5 and positive 10 is not included, then we will not put an underline or equal. So in equality notation, we have positive 5 is less than h and h is less than 10. Set builder notation, we have the set of all h such that 5 is less than h and h is less than 10. So interval notation, we have parentheses. Since positive 5 is not shaded or not included, then positive 10 is also not shaded or not included, so we will use parentheses. Next, another example. Okay, for our fourth example, we have positive 10, not shaded or not included, so we will not put an underline or equal. Next, as you can see, we have an arrow going to our left, which is our negative side. Okay, so remember, left side, negative side, right side, positive side. Okay, so in equality notation, we have h is less than 10. Set builder notation, we have the set of all h such that h is less than 10. Interval notation, we have negative infinity. Since we have an arrow going to left, which is a negative side, then we will put negative infinity since it is continuous. Next, positive 10, not shaded or not included. So we will use parentheses. Next, another example. Positive 10, shaded or included. Then we will put an equal or underline. And as you can see, we have an arrow going to right, which is positive side. So in equality notation, we have the set, we have h greater than or equal to 10. Then for our set builder notation, we have the set of all h such that h is greater than 10. Next, interval notation. Since positive 10 is shaded or included, so we will use square bracket. Then, since we have an arrow going to right, which is going to positive, so we will use positive infinity. Next, okay, so for our next example, we have both continuous arrow going to left or negative side and going to right or positive side. So for inequality notation, we have all real numbers. Since it is continuous on both sides, then set builder notation we have R, which stands for real numbers. Again, so since it is continuous on both sides, we have negative infinity to positive infinity. Okay? Okay, next, let's have another example. We have positive 9 shaded. Sorry, we have negative 9 shaded or included. And positive 4 not shaded or not included. So, since negative 9 is shaded or included, so we will put an underline or equal. And for positive 4, which is not shaded or not included, then we will not put an underline or equal. So in equality notation, we have negative 9 less than or equal to x, and x is less than 4. Next, the set of all x values such that negative 9 is less than or equal to x, and x is less than 4. Since for our interval notation, we have, since negative 9 is shaded or included, so we will use square bracket. And for positive 4, which is not shaded or not included, we will use parentheses. Okay? So next, next, we have negative 6 shaded or included, and positive 3 not shaded or not included. Okay, so negative 6 is, is shaded or included, so we will put an underline or equal. Since positive 3 is not shaded or not included, then we will not put an equal or underline. So for our inequality notation, we have negative 6 is less than or equal to x, and x is less than 3. Next, set builder notation, we have the set of all x such that negative 6 is equal less than or equal to x, and x is less than 3. Next, since negative 6 is shaded or not included, then we will use square bracket. Next, positive 3, not shaded or not included, so we will use parentheses. Next, we have negative 12, not shaded or not included, and positive 8, which is shaded or included. Since negative 12 is not shaded or not included, so we will not put an equal or underline. And since positive 8 shaded or included, so we will put an underline or equal. So for our inequality notation, we have negative 12 is less than x and x is less than or equal to 8. Next, for our set builder notation, we have the set of all x such that negative 12 is less than x and x is less than or equal to 8. Next, interval notation. Since negative 12 is not shaded or not included, then we will use parentheses. Next, positive 8 shaded or included, so we will use square bracket. Okay? Okay, for our recap, we discussed about functions and relation. So we have types of relation. Types of relations which are one to one to many, and many to one. And that next for our function, we have set of ordered pairs, table of values, mappings, graph, and equation. Okay? So for set of ordered pairs, table of values, mappings, and graph, we will focus on x coordinate or the domain if it is unique or not repeated, then it is considered as function. Then if it is repeated, it is considered as relation. Then in equation, we will focus on y coordinate, y variable, or the range. If its exponent is an odd number, then it is considered as function. Then if the exponent of y is an even number, then it is considered as relation. Okay? For our set builder notation, terms to remember. So the brackets, the set of vertical bar means such that shaded dot included, square bracket included, not shaded dot means not included, parentheses means not included. Then arrows means continuous. Okay? Okay, so that's all for our module 2. Now let's proceed to our module 3. Okay, so good day everyone. Again, I am Miss Leona May Cervantes. You can call me Miss Leona, your teacher for General Mathematics. Now let's discuss our Module 3. So Module 3, Learning Competencies. The learner can evaluate a function. The learner can perform addition, subtraction, multiplication, division, and composition of functions. Next, the learner can solve problems involving functions. Next, next, evaluating function. In the previous lesson, we learned the difference between a function and relation. Now, in this lesson, we will talk about function on how to evaluate the function and the different operations of functions. So before we proceed on the evaluation, let us examine this example. Given that y equals x squared plus 10x plus 25, what is the value of y if x is equal to 1? Okay, so if x is equal to 1, we will just substitute positive 1 to our x. Okay, so we have y equals 1 squared plus 10 times 1 plus 25. So y plus equals 1 plus 10, since 10 times 1 is 10, and plus 25. So we have y is equal to 36. So if is equal to 1, then the value of y is positive 36. Next, so as we observe in the given problem, we only want to know the certain value of y if we give value for x. In that case, the same repetition of question being asked. That's why mathematical expert has a convention which they decided that instead of using the question, what is the value of y if x is equal to a certain value, they will represent y as f of x or a function. Next, observe the process of replacing the variable in the function to generate an output. So given given is f of x equals x squared plus 10x plus 25. So if x is equal to 1, so f of 1 is equal to 1 squared plus 10 times 1 plus 25. 1 squared is equal to 1. 10 times 1 is equal to 10 plus 25. So f of 1 is equal to 36. So in the given f of x is equal to x squared plus 10x plus 25. If x is equal to 1, then f of x or f of 1 is equal to 36. Next, now if x is equal to 2 or f. So we have f of 2, then substitute positive 2. Okay. So we have 2 squared plus 10 times 2 plus 25. So we have 2 squared is equal to 4. 10 times 2 is equal to 20 plus 25. So we have f of 2 is equal to 49. Okay. Next. Okay, so let's have another example. Given f of x is equal to x squared minus 2x plus 2. Okay, so if x is equal to 1, substitute. So now we have 1 squared. Okay, so x squared, now we have 1 squared plus 2 times 1 plus 2. So we have 1 squared is equal to 1 plus 2 times 1, which is 2, and plus 2. So f of 1 is equal to 5. Next, if x is equal to 2, so we have f of 2, substitute positive 2. So now we have 2 squared plus 2 times 2 plus 2. We have 2 squared is equal to 4. 2 times 2 is also equals to 4 plus 2. So we have positive 10. So if x is equal to 2, then the value of y or f of x is positive 10. Okay, so remember that the y or the range is also the same in the function of x or f of x. Next, let's proceed to operation of functions. Okay, so now let's have addition. Given f plus g of x is equal to f of x plus g of x. So for example, the value of f of x is x squared plus 12. And the value of g of x is 6x minus 3. Now, let's find the f plus g of x. So f plus g of x is equal to x squared plus 12, which is the value of f of x. Okay? Then plus, since we're discussing about addition, again, x squared plus 12, which is the value of f of x, plus the value of g of x, which is 6x minus 3. Now, let's add. So we have x squared plus 12 plus 6x minus 3. So we have x squared then 6x 12 minus 3 is equal to 9. Okay? Okay, so f plus g of x, if the value of f of x is x squared plus 12 and g of x is equal to 6x minus 3, then f plus g of x is equal to x squared plus 6x plus 9. Okay? Now, let's have another example. Okay, so if x is equal to 2, again, the value of f of x is x squared plus 12. G of x is equal to 6x minus 3. Now, if x is equal to 2, then we will substitute pos positive 2 to x. Okay, so we have x squared plus 12 for the value of f of x and 6x minus 3 for the value of g of x. So now, substitute positive 2. So we have 2 squared plus 12 plus 6 times 2 minus 3. Next, 2 squared is equal to 4 plus 12 plus 6 times 2 is equal to 12 and minus 3. 4 plus 12 is equal to 16. 12 minus 3 is equal to 9. Then now, 16 plus 9 it is equal to 25. So if x is equal to 2, then f plus g of x is equal to 25. Okay? Okay, so now let's have another example for artisan. F plus g of x equals f of x plus g of x. Now, if the value of f of x is x squared plus 15, and the value of g of x is 5x minus 3, then f plus g of x is equal to x squared plus 15, value of f of x, value of g of x is 5x minus 3. Okay? Now let's add x squared plus 15 plus 5x minus 3. So we have x squared plus 15 plus 5x minus 3. So we have x squared then 5x then 15 minus 3 is equal to 12. Okay? So f plus g of x is equal to x squared plus 5x plus 12. Okay? Next, if x is equal to 2, again, the value of f of x is x squared plus 15. Substitute positive 2. And the value of g of x is 5x minus 3. Substitute. Okay, so we have 2 squared plus 15 plus 5 times 2 minus 3. So we have 2 squared is equal to 4 plus 15 plus 5 times 2 is equal to 10. Then minus 3. So we have 4 plus 15 is equal to 19 plus 10 minus 3 is equal to 7. Now we have 19 plus 7. So we have 26. So we have typographical error here. So f plus g of x, if x is equal to 2, is equal to 26. Okay, next. So again, this is 26. Okay, 19 plus 7 is equal to 26, not 16. Okay, next. Let's have another example for addition. So f plus g of x is equal to f of x plus g of x. So for example, the value of f of x is 2x squared plus 13, and the value of g of x is 4x minus 7. So again, so for f of x, we have 2x squared plus 13, and for g of x, we have 4x minus 7. Okay, so now let's add 2x squared plus 13 plus 4x minus 7. So we have 2x squared plus 13 plus 4x minus 7. So bring down 2x squared and 4x. Then 13 minus 7 is equal to 6. Okay? So f plus g of x is equal to 2x squared plus 4x plus 6. Okay? Next, if x is equal to 2, again, the value of f of x is 2x squared plus 13. Okay, Okay, sorry. So let's proceed. F of x is equal to 2x squared plus 13. So 2, we have 2. Okay, so 2 times 2 squared plus 13 plus 4 times 2 minus 7. So 2 times 2 times 2 squared is equal to 8 plus 13. Then 4 times 2 is equal to 8 minus 7. So we have 8 plus 13 is equal to 21. 8 minus 7 is equal to 1. So 21 plus 1 is equal to 22. So if x is equal to 2, then f plus g of x is equal to 22. Next, okay, so now let's proceed to subtraction. So f minus g of x equals f of x minus g of x. Next, for example, the value of f of x is equal to x squared plus 12 and g of x is equal to 6x minus 3. So again, x squared plus 12, value of f of x minus 6x minus 3, which is the value of g of x. So we have x squared plus 12 minus 6x plus 3. So we have x squared minus 6x, then 12 plus 3 is equal to 15. Okay, so next. Again, the value of f of x is equal to x squared plus 12. If x is equal to 2, so we have 2 squared plus 12. And the value of g of x is 6x minus 3. So we have 6 times 2 minus 3. 2 squared is equal to 4 plus 12 minus 6 times 2 is equal to 12 minus 3. So we have 4 plus 12 is equal to 16 minus 12 minus 3 is equal to 9. So 16 minus 9 is equal to 7. So f minus g of x, if x is equal to 2, is equal to 7. Next, another example for subtraction. We have f minus g of x equals f of x minus g of x. So we have the value for f of x is equal to 3x squared plus 15. And for g of x, we have 5x minus 2. Okay, so we have 3x squared plus 15 for f of x, 5x minus 2 for g of x. Okay, so 3x squared plus 15 minus 5x, then plus 2. Sorry. So this is plus 2. Okay, so again, we have 3x squared plus 15 for f of x, 5x minus 2 for g of x. So 3x squared plus 15 minus 5x minus 2. So 3x squared plus 15 minus 5x, then plus 2. Next, we have 3x squared minus 5x, then 15 plus 2 is equal to 17. Next, okay, so next, again, the value for f of x is 3x squared plus 15. So we have 3 times 2 squared plus 15 minus g of x is 5x minus 2. So we have 5 times 2 minus 2. Okay. So 3 times 2 squared is equal to 12. Next, plus 15 minus 5 times 2 is equal to 10. Then minus 2. 12 plus 15 is equal to 27. Minus 10 minus 2 is equal to 8. 27 minus 8 is equal to 19. So f minus g of x, if x is equal to 2, then it is equal to 19. Okay? Next. Okay, so another example for subtraction. F minus g of x is equal to f of x minus g of x. So for example, the value of f of x is equal to x squared plus 4, and the g of x is equal to x minus 2. Okay, so again, f of x is equal to x squared plus 4, x minus 2 for g of x. So we have x squared plus 4 minus x plus 2. Okay, so like signs, kaya siya naging plus 2. Okay, so now we have x squared plus 4 minus x plus 2. So we have x squared minus x, 4 plus 2 is equal to 6. Next, if x is equal to 2, so we have x squared plus 4. So 2 squared plus 4. And for g of x, we have x minus 2. So we have 2 minus 2. 2 squared is equal to 4 plus 4 minus 2 minus 2. 4 plus 4 is equal to 8. 2 minus 2 is equal to 0. So 8 minus 0 is equal to 8. If x is equal to 2, then f minus g of x is equal to 8. Okay? Next. Okay, so now let's proceed to multiplication. So we have f times g of x is equal to f of x times g of x. So for example, the value of f of x is x squared plus 12, and the value of g of x is 6x minus 3. Find f times g of x. So we have x squared plus 12 times x minus 3. Okay, so we're using the FOIL method. First, we have, sorry, I forgot 6x. Okay, so we have 6x squared Okay, sorry. So again, we have x squared plus 12 and 6x minus 3. So using the FOIL method, we have x squared times 6x is equal to 6x cubed. Then we have x squared times negative 3 is equal to 3x squared, negative 3x squared. Next, 12 times 6x is equal to 72x, and 12 times negative 3 is equal to negative 36. So f times g of x is equal to 6x cubed minus 3x squared plus 72x minus 36. Okay? Okay, so if x is equal to, then we have x squared plus 12. So 2 squared plus 12 and 6x minus 3. So 6 times 2 minus 3. 2 squared is equal to 4 plus 12. 6 times 2 is equal to 12 minus 3. 4 plus 12 is equal to 16. 12 minus 3 is equal to 9. Then 16 times 9 is equal to 144. Okay, so if x is equal to 2, then f times g of x is equal to 144. Next, let's have another example for multiplication. We have f times g of x equals f of x times g of x. So f of x is equal to x squared plus 8. G of x is equal to 2x minus 3. So x squared plus 8 times 2x minus 3. Again, FOIL method, we have first x squared times 2x is equal to 2x cubed. Then x squared times negative 3 is equal to negative 3x squared. 8 times 2x, we have plus 16x. Then 8 times negative 3 is equal to negative 24. So we have f times f times g of x is equal to 2x squared, 2x cubed minus 3x squared plus 16x minus 24. Next, find f times g of x if x is equal to 2. Again, the value of f of x is x squared plus 8. So we have 2 squared plus 8. Then for g of x, we have 2x minus 3. So 2 times 2 minus 3. 2 squared plus 8. So 2 squared is equal to 4 plus 8. 2 times 2 is equal to 4 minus 3. 4 plus 8 is equal to 12. 4 minus 3 is equal to 1. So 12 times 1 is equal to 12. If x is equal to 2, f times g of x is equal to 12. Next, another example for multiplication. We have f times g of x equals f of x times g of x. So for example, the value of f of x is equal to x squared plus 5. and the value of g of x is equal to 3x minus 4. Find f times g of x. So again, the value of f of x is x squared plus 5. And the value of g of x is equal to 3x minus 4. Again, FOIL method, we have x squared times 3 of x, 3x, sorry. So we have 3x cubed next x squared times negative 4. So we have negative 4x squared. Next, 5 times 3x. So 5 times 3 is equal to 15. So we have positive 15x. Next, 5 times negative 4. We have negative 20. So if f of x is equal to x squared plus 5 and g of x is equal to 3x minus 4, then f times g of x is equal to 3x cubed minus 4x squared plus 15x minus 20. Okay? Next, if x is equal to 2, then f times g of x is equal to f of x, you have x squared plus 5. So 2 squared plus 5. And for g of x, we have 3x minus 4. So we have 3 times 2 minus 4. Okay? So 2 squared is equal to 4 plus 5. 3 times 2 is equal to 6 minus 4. 4 plus 5 is equal to 9. 6 minus 4 is equal to 2. 9 times 2 is equal to 18. So if x is equal to 2, then f times g of x is equal to 18. Okay, so next. Okay, so now let's proceed to division. We have f divided by g of x. We have f of x divided by g of x. So for example, the value of f of x is equal to x squared plus 12, and the value of g of x is x minus 3. So we have f divided by g of x is equal to x squared plus 12, which is the value of f of x, and below 6x minus 3, which is the value of g of x. So f divided by g of x is equal to x squared plus 12 divided by 6x minus 3. Okay, so next. Okay, again, the value of f of x is x squared plus 12. So we have 2 squared plus 12. Then g of x, we have 6x minus 3. So 6 times 2 minus 3. 2 squared is equal to 4 plus 12 divided by 6 times 2 is equal to 12 minus 3. So we have 4 plus 12 is equal to 16. And 12 minus 3 is equal to 9. So if x is equal to 2, then f divided by g of x is equal to 16 over 9. Okay. Next. Another example for division, we have f divided by g of x equals f of x divided by g of x. For example, the value of f of x is x squared plus 10. And for g of x, we have 5x minus 2. So we have f divided by g of x is x squared plus 10 divided by 5x minus 2. So f divided by g of x is equal to x squared plus 10 divided by 5x minus 12. Next, if x is equal to 2, then f divided by g of x is equal to, again, f of x, we have x squared plus 10. So we have 2 squared plus 10. For g of x, we have 5x minus 2. So 5 times 2 minus 2. 2 squared is equal to 4 plus 10. 5 times 2 is equal to 10 minus 2. 4 plus 10 is equal to 14. 10 minus 2 is equal to 8. So f divided by g of x is equal to 14 over 8. Okay? Now, let's have another example for division. We have f divided by g of x is equal to f of x divided by g of x. So, for example, f of x is equal to x squared plus 5. And g of x, we have x minus 1. So, x squared plus 5, then x minus 1. So, f divided by g of x is equal to x squared plus 5 divided by x minus 1. Okay? So, next, if x is equal to 2, then f divided by g of x is equal to f of x squared minus 5. Sorry, x squared plus 5. So we have 2 squared plus 5. For g of x, we have x minus 1. So 2 minus 1. 2 squared plus 5. We have 4 plus 5. 2 minus 1. 4 plus 5 is equal to 9. 2 minus 1 is equal to 1. So we have 9 over 1 or 9. If x is equal to 2, then f divided by g of x is equal to 9 over 1 or 9. Okay? Now let's proceed to composition of function. In composition of function, we will substitute the value of x. Okay? So we have f composition of g of x is equal to f with g of x. So for example, the value of f of x is x squared plus 12. And g of x, we have 6x minus 3. Okay, so we will substitute the value of x with the value of g of x, which is 6x minus 3. Okay? So for example, we will remove x or substitute x by 6x minus 3. Okay? Squared. So this is squared. Okay, sorry. Plus 12. Then we have 36x squared minus 36x plus 21. Okay? Okay, so we have 6x minus 3 squared plus 12. So expand 6x minus 3 times 6x minus 3. So we have 6x times 6x is equal to 3x squared, 36x squared, then 6x times negative 3 is equal to negative 18x, then negative 3 times 6x is equal to negative 18x. So negative 18x and negative 18x is equal to negative 36. Okay? Then plus, sorry, I forgot. Negative 3 times negative 3 is equal to positive 9. So we have 36x squared minus 18x minus 18x plus 9 plus 12. So simplify, we have 36x squared minus 36x, 12 plus 9 is equal to 21. Okay? So F composition of g of x, if f of x is equal to x squared plus 12 and g of x is equal to 6x minus 3. So F composition of g of x is equal to 36x squared minus 36x plus 21. Okay, next, F composition of g of x, if x is equal to 2. Again, the value of f of x is x squared plus 12. we will substitute the x with the value of g of x. So 6x minus 3. 6x minus 3. So substitute positive 2. 6 times 2 minus 3 squared plus 12. Okay. So we have 6 times 2 is equal to 12 minus 3 squared plus 12. So we have 12 minus 3 is equal to 9 squared plus 12. So 9 squared is equal to 81 plus 12. Then f composition of g of x, if x is equal to 2, is equal to 93. Okay? Next example for composition of function. So we have again f composition of g of x is equal to f with g of x. So the value of f of x is x squared plus 12. For g of x, we have x minus 3. Again, we will substitute the value of x with the value of g of x. Okay? So x minus 3. Okay? Squared plus 12. So we have x squared minus 6x plus 9. Okay, so we have x minus 3 and another x minus 3. Then plus 12. Okay, so we have first x times x is equal to x squared. X times negative 3 is negative 3x. Negative 3 times x, negative 3x. Negative 3x and negative 3x is equal to negative 6x. Okay? Then negative 3 times negative 3 is equal to positive 9. Then positive 12 plus positive 9 is equal to okay, sorry again. X minus 3 and x minus 3. So we have x times x squared, x times negative 3, negative 3x. Negative 3x times x is equal to negative 3x. So we have negative 6x. Then negative 3 times negative 3 is equal to positive 9. So positive 12 plus positive 9 is equal to positive 21. So we have f composition of g of x equal to x squared minus 6x plus 21. Okay? Next, f composition of g of x. Fx is equal to 2. We have f of x is equal to x squared plus 12. Substitute x with the value of g of x. So we have x minus 3. So positive 2 minus 3 squared plus 12. So we have 2 minus 3 is negative 1 squared plus 12. So we have negative 1 times negative 1 is equal to positive 1 plus 12. So we have 1 plus 12 is equal to 13. So f composition of g of x, if x is equal to 2, then it is equal to 13. Okay? Next, another example, we have composition of function, f composition of g of x is equal to f with g of x. So the value of f of x is equal to x squared plus 9. G of x, we have 2x minus 3. Next, f composition of g of x is equal to, again, substitute the value of x with the value of g of x. So value of g of x is 2x minus 3. Then squared plus 9. Okay. So 2x minus 3. So 2x times 2x is equal to 4x squared. Then 2x times negative 3 is equal to 6x, negative 6x. And negative 3 times 2x is equal to negative 6x. Negative 6x and negative 6x is equal to negative 12x. Then, plus, sorry, negative 9 plus negative 9 times negative 3 times negative 3 is equal to positive 9. So, positive 9 plus positive 9, we have 18. Okay. So, f composition of g of x is equal to 4x squared minus 12x plus 18. Okay? Again, f composition of g of x is equal to 4x squared minus 12x plus 18. Okay? Next, value of f of x is x squared plus 9. Then substitute the value of x with the value of g of x. So the value of g of x is 2x minus 3. So we have 2 times 2 minus 3. Okay. So we have 2 times 2 is equal to 4 minus 3 squared plus 9. 4 minus 3 is 1 squared That's 9. 1 times 1 is equal to 1 plus 9. F of g of x, if x is equal to 2, then it is equal to 10. Okay? So that's all for today. Thank you for watching or for listening.